Example 4.2, looking at payment methods. So there was a poll done in 2011 by Associated Press and GFK Roper Public Affairs, and asked a random sample of consumers who have a debit card whether they would keep or switch to another payment method if they were charged a certain fee a month, $3, $5, or $7. And the information is summarized in the table below. Now, what are we asked? Number one, determine the probability that a randomly selected consumer A keeps using their debit card. All right. Well, first of all, we need to figure out, do we have totals? And the answer is no. We don't know the total number of people here who they surveyed. They don't tell us the number, and we don't have a total column. But can we compute these? Most definitely. So I'm going to add total here and total here. And then I'm going to add across, obviously, hopefully, to get the total for the number of keep, the number that switch, and then the totals by the dollar amounts. Remember, the totals across should equal the total down. So take a minute and see if you can, well, use your calculator, add them up. Please pause, take a moment, and make sure that your numbers match what I have for totals here. So the first probability keeps using their debit card. So I'm going to use, well, we'll just write it out actually. P, probability they keep using the debit. Is there a condition there? Well, you're like, well, you just wrote it without a condition. There must be no condition. There is no condition, but why do I say that there's no condition? We're just asked if they keep using their debit card, regardless of anything else going on. So that probability is out of the 695. What's the probability they keep using, or how many keep using their debit card? And that's 209. And you end up with 0.301. So they keep using their debit card. You could do probability keep debit, something like that, that makes it clear what probability you're finding. Now, B said keeps using if the fee is $3. Well, now let's think about it. Is there a condition? Well, yes, we're not interested in whether they keep using their debit card or not. We're interested in only those people, if they charge $3, what the probability is that they will keep using their debit card. So the probability, let's see, what's the condition and what is not the condition? Hopefully you can say, okay, well, if the fee is $3, so there's my condition that I'm only interested in the people who, when it's $3, and they keep using their debit. And I'll do keep D for debit. How many people did they survey and ask about $3 fee? Well, it was 239. How many said for $3 that they would keep using their debit card? And that is 91. And that ends up being 0.381. Please complete C and D on your own and then come back and check your answer. So, excuse me, please take a moment, check. Now, B, C, and D are all examples of conditional probability, the conditions being how much is paid. As we look at these, what happens as the amount that is going to be charged to keep using that debit card goes up? Well, hopefully you notice the probability that they're going to keep it goes down. That makes sense. If someone told me that they were going to charge me, let's say $3, personally, I probably wouldn't keep using my debit card. I would go to something else. And if they said $7 was the charge, I definitely wouldn't keep it. Now, does the decision to keep or switch depend on the fee? And we see, yes, we already answered that. So we'll call this number 1 and this number 2 here. What did we find? As the fee goes up, the probability of keeping the debit card goes down. So is the decision independent of the fee? Well, no. It is not. We see that. How much the fee is affects what the probability of keeping it goes. Keeping, blah, blah, blah. Let me try that again. English, excuse me, the decision independent. No, we can see that the fee does affect the probability of whether you're going to keep it or not.